Have you ever bitten into a French fry that was crispy, golden, perfectly crunchy on the outside and soft on the inside and wondered, what's in this potato? Why do homemade fries never taste quite like McDonald's fries? Now imagine discovering that the frozen McCain fries sitting in the grocery store freezer come from the same industrial world that supplies the fast food giant. And here's the surprise. These potatoes aren't simply cut and frozen. Before they ever reach the bag, they're selected in the field, washed on an industrial scale, steam peeled, sliced by high-pressure water, blanched, dried, par-fried, flash frozen, and tested. Also, they won't let you down when you open the bag at home. This isn't just a potato that gets sliced and tossed into a freezer. It comes to life inside a massive industrial chain with carefully planned farms, enormous harvesters, factories filled with steam, oil monitored by sensors, and freezing tunnels so cold they lock in the potato's texture within minutes. Welcome to Factories and Facts. Today, you're going behind the scenes of one of the most mesmerizing products in the food industry, frozen French fries. They may look simple inside the bag, but before they ever reach your fryer, they go through an astonishing feat of engineering. Companies like McCain, Lamb Weston, and Simplot help turn these golden strips into a global industry. They produce frozen fries for grocery stores, restaurants, and food service operations across multiple countries, supplying a market that demands one thing above all else: consistency. And in our previous episode, we showed how corn has to become dough, triangles, and a crunchy layer of seasoning before it turns into Doritos. Here, the challenge is completely different. Taking a natural potato, irregular and full of variation, and transforming it into nearly identical fries with the same color, texture, and crunch. Every fry needs to be roughly the same size, the same color, the same texture, and behave predictably the moment it hits the hot oil. So, subscribe to Factories and Facts, because today's question is simple and impossible to ignore. How does a dirt-covered potato, pulled from the ground by massive machines, become a golden crispy fry that looks almost identical to the thousands rolling out of a factory every single day? It all begins long before the potatoes reach the factory, out in the fields. But don't be fooled. A farm supplying the frozen French fry industry is far more than a patch of land filled with ordinary potatoes. It is a precisely planned operation. Every detail, from the soil and water to the variety and harvest, can determine whether a potato becomes a picture-perfect fry or gets rejected before it even reaches the production line. From above, the field looks like a green carpet divided by perfectly straight rows. Beneath the soil, thousands of potatoes grow out of sight, slowly swelling in silence. And this is where one of the process's biggest surprises begins. Not every potato can become a frozen French fry. For the industry, the ideal potato must be long, firm, high in dry matter, and low in sugar. That may sound like a minor detail, but it changes everything. A potato with too much sugar can turn far too dark during frying. A potato with too much water can become soft and fragile. And a potato that is too small produces short fries that fall outside the required standard. That is why growers use specific varieties selected for length, texture, and yield. The industry wants potatoes that produce long, uniform, durable fries, because every inch matters when millions of pieces move through the factory. The more uniform the raw potatoes are, the less waste is created during cutting. The easier it becomes to control their color during frying, and the more likely every bag is to have a consistent appearance. The soil is also part of this engineering. In many growing regions, potatoes perform best in well-drained, well-aerated ground with minimal compaction. Think of a potato as a product that must develop underground without being crushed, misshapen, or bruised. If the soil is too hard, it may grow crooked. If rocks are present, they can cut its surface. And if irrigation fails, growth becomes uneven. And if too much rain falls at the wrong time, harvesting can turn into a race against the clock. Irrigation creates some of the most beautiful scenes at this early stage. Massive metal arms rotate slowly across the fields, spraying water over enormous circles. It looks peaceful, almost effortless, but every drop is calculated. Too much water can encourage disease and alter quality. Too little reduces size and yield. The factory needs potatoes that are large, healthy, and predictable. So the field acts as the first stage of the production line, only under the open sky. Long before these potatoes leave the ground, countless factors have already been monitored. Technicians evaluate average size, solids content, sugar levels, skin maturity, and the overall condition of the crop. In some cases, samples are pulled before harvest to predict how the batch will perform after being washed, cut, par-fried, and frozen. It may sound excessive to test a potato while it is still in the field, but imagine discovering too late that tons of them will not fry to the right color. When harvest time arrives, the spectacle begins. Enormous machines move slowly through the rows, lifting the soil as though they were peeling open the ground. They reach underneath, loosen the earth, pull up the tubers, and carry everything onto vibrating conveyors that shake the mixture apart, separating potatoes from soil, leaves, and small clumps of dirt. It is almost like watching a giant moving sieve at work. The remarkable part is that harvesting must be powerful enough to pull tons of potatoes from the soil, yet gentle enough to avoid damaging them. A potato that is struck, cut, or crushed can create problems later. Damage that looks minor in the field may darken afterward, ruin the appearance of the fry, or cause that potato to be rejected during inspection. That is why machine speed, drop heights along the conveyors, and even handling inside the trucks must be carefully controlled. And here, one image captures the scale of it all. Trucks being loaded with mountains of freshly harvested potatoes. Each trailer carries part of the crop toward an entirely new industrial life. What was buried underground only minutes ago has now become raw material for a global supply chain capable of stocking grocery stores, restaurants, diners, and major food service chains. But transportation also requires care. Potatoes cannot be handled like rocks. If they are dropped from excessive heights, they can suffer internal bruising. If they remain exposed to poor conditions for too long, their quality can deteriorate. And if a load contains too many potatoes that fall outside the standard, the factory will eventually uncover the problem. So even before reaching the plant, every truckload represents a bet on the quality delivered by the field. There is another surprising detail. The perfect frying potato is not necessarily the best-looking potato you would choose in the produce aisle. At the grocery store, most people judge potatoes by their skin and overall appearance. The industry cares about what they deliver after cutting and frying. A large, elongated potato with a high solids content may be far more valuable than a smooth, perfectly round one because it produces longer fries, browns more evenly, and loses less water. That is why frozen French fries begin with so much hidden science. Before there is a bag, a freezer, hot oil, or an air fryer, a silent battle takes place in the field to produce the right tuber. The industry does not merely need potatoes. It needs potatoes with predictable behavior, capable of surviving steam, blades, hot water, oil, freezing, and transportation without losing their texture, color, or shape. And if you are enjoying watching this transformation unfold from the ground up, hit the like button, because the final crunch begins months earlier, while the potato is still buried beneath the soil. After harvesting, the trucks head to the factory or to storage facilities. The potatoes are still dirty, uneven, and covered with marks from the field. But in the next stage, they undergo an astonishing transformation. Tons of raw potatoes enter from one side, and shortly afterward, pale, uniform fries move toward the heart of the factory. When the trucks arrive at the factory, the potatoes still look nothing like the golden fries inside the bag. They come covered in dirt, with bits of leaves, clumps of soil, and small hidden rocks. This is where the industry begins a rigorous sorting process, separating the potatoes that can become frozen French fries from those that cannot move any farther down the line. The first thing you notice is the scale. Trucks unload tons of potatoes into receiving areas, and the product begins moving through water channels or across wide conveyor belts. The water helps cushion the impact while loosening the heaviest dirt. It may look like an enormous washing system, but it also protects the potatoes. Right from the start, separation systems remove rocks, hardened clumps of soil, and other materials carried in from the field. This is essential because even a small stone can damage equipment, blades, and pipes. In a continuous flow factory, a single foreign object can bring the entire line to a stop. Then comes the intensive washing stage. The potatoes pass through water jets, rotating drums, and industrial brushes that scrub away dirt clinging to the skin. The sight is striking. Thousands of potatoes spinning, gently knocking against one another and gradually losing the rough appearance of something freshly pulled from the ground. Once the clean skin is exposed, the factory can detect blemishes, cuts, green areas, and other defects. At this stage, potatoes are not judged by appearance alone. What the industry is looking for is consistency. Rotten, undersized, misshapen, green, or bruised potatoes may be removed from the line. Depending on the facility, this sorting process can involve workers, cameras, sensors, and mechanical separators. The goal is to prevent a small defect from later becoming a dark, broken, or off-spec fry. After washing comes one of the most impressive stages: peeling. At home, most people picture knives and blades. In large-scale industrial operations, however, pressurized steam is often used. The potatoes enter a sealed chamber, receive a blast of hot steam for just a few seconds, and when the pressure changes, the skin loosens from the surface. It is almost as though the factory persuades each potato to shed its own skin. Brushes and water jets then strip away the softened peel, revealing the pale flesh underneath. The process has to move quickly because the line handles tons every hour. These potatoes cannot wait around the way they would in a home kitchen. Steam also helps reduce waste because it removes the skin without stripping away as much flesh as more aggressive methods. At an industrial scale, wasting even a thin layer across millions of potatoes can mean losing tons of perfectly usable product. From this point on, the potato has already taken on a new identity. It arrived from the field dirty and uneven, passed through water, separation, inspection, and steam, and is now clean, pale, and ready to be cut. Before we continue, tell us in the comments, what city and state are you watching from? I want to know where everyone is tuning in from who also finds it mesmerizing to watch a factory transform something simple into a perfectly finished product. And now you are about to watch the potato finally become the familiar fry everyone recognizes. But cutting is only the beginning. Next comes sizing, blanching, drying, and par frying, the secret behind that signature crunch. Now the clean potato enters the stage where everything starts to look familiar. Until this moment, it was still a whole tuber, pale, moist, and peeled. But within seconds, this raw ingredient will become hundreds of nearly identical fries, gliding along conveyor belts as though each one had been individually designed. Industrial cutting is one of the most impressive sights inside the factory. On many production lines, potatoes are propelled by high-speed water directly into fixed blades. It may sound unusual, but the logic is brilliant. Instead of a knife coming down on each potato, the force of the water drives it through a cutting grid. The result is long, straight fries produced far faster than any manual cutting method could ever achieve. But cutting alone is not enough. The industry also needs uniformity. Fries that are too large, too small, too thin, crooked, broken, or blemished can be separated out. Smaller pieces may be redirected into other products, including specialty potato shapes, flakes, or industrial ingredients. Nothing is treated as an afterthought because every leftover piece represents money, energy, water, and production time. This is where many people discover the truth behind a common misconception. Frozen French fries are not simply raw potatoes that have been cut and frozen. If they were, they would reach your kitchen with uneven texture, unpredictable color, and a much greater chance of turning soft after cooking. The real secret lies in the invisible stages that happen before they ever reach the freezer. After cutting, the fries are washed to remove some of the loose starch from the surface. If too much starch remains, the fries can stick together, darken during frying, and develop the wrong texture. Then comes blanching, a step that looks simple but changes everything. During blanching, the fries pass through hot water or controlled steam for a precise amount of time at a carefully regulated temperature. The goal is not to cook the potato completely, but to prepare its internal structure. This stage helps remove surface sugars, even out the color, reduce unwanted reactions, and begin changing the texture. It is almost as if the factory is giving each fry its first instruction. You are going to brown exactly the way you should. After blanching, the fries move into the drying stage. It may seem subtle, but it plays a major role in creating that final crunch. Hot air circulates around the fries, drawing moisture from the surface. If they enter the oil too wet, frying becomes less efficient, energy consumption rises, and the final texture suffers. The industry wants a surface that is ready to form the golden crust everyone expects. Then comes the stage that surprises most people, par frying. Yes, frozen French fries are usually partially fried before they ever reach the bag. They pass through hot oil for a carefully controlled amount of time, long enough to form an outer layer, begin browning, and develop flavor without fully cooking the potato. That is why when you place frozen fries in an air fryer, oven, or deep fryer, they are not starting from scratch. They are finishing a process that began inside the factory. Now, consider the scale of it all. We are not talking about a small batch. We are talking about conveyors loaded with fries, oil circulating through industrial systems, filters removing particles, temperatures held under constant control, and enormous volumes passing through a few decisive seconds. A minor mistake at this stage can compromise tons of product. And here is another fascinating detail. The appearance you see inside the bag is no accident. The factory aims for fries with similar lengths, a light color, and an even surface because consumers associate those traits with quality. Major restaurant chains also depend on that consistency. When an operation serves thousands of portions every day, each batch cannot behave differently. The fries need to cook quickly, brown predictably, and deliver the same crisp bite again and again. That is why global frozen potato companies have grown so large. They are not merely selling potatoes, they are selling predictability. They are selling a product that can leave a farm, pass through a complex factory, travel under frozen conditions, and still deliver a remarkably similar texture in kitchens across the world. By the end of this stage, the potato no longer resembles a raw agricultural product. It has become a highly processed food, cut, washed, sorted, blanched, dried, and par-fried. But one critical step still remains. If the fries cool too slowly or freeze unevenly, all of that work can be lost. Next, the fries enter extreme cold freezing tunnels, where every piece must be frozen rapidly to preserve texture, prevent clumping, and prepare the product for shipment around the world. After par frying, the fries are still hot, delicate, and vulnerable. They already have their shape, an initial golden color, and an outer layer designed to become crispy. But if they cool too slowly, some of that texture can be lost and the fries may stick together. That is why the next stage is one of the most important in the entire factory: rapid freezing. The fries travel along conveyor belts into intensely cold tunnels, where high-speed currents of freezing air circulate around them. The goal is to freeze each piece individually rather than turn everything into one solid block of potatoes. This rapid freezing process helps preserve the structure created during the earlier stages and keeps the fries loose inside the bag. That is why, when you open a package at home, you can pour out a serving without having to break apart a frozen brick. The scene is almost cinematic. A conveyor loaded with golden fries enters an icy tunnel, and on the other side, a firm, stable product emerges, ready to travel. Within minutes, the fry that began in the field and passed through steam, blades, hot water, and oil is now protected by the cold. But the factory is not finished yet. After freezing, sensors, cameras, and operators continue inspecting the product. Fries that are broken, too dark, too pale, or outside the required size range may be removed. On some lines, detection systems also search for foreign materials before packaging. The goal is straightforward. Every bag must deliver the same standard, whether it ends up in a grocery store, a restaurant, or a large-scale food service operation. At the packaging stage, everything happens fast. Machines dispense the correct amount, weigh each portion automatically, seal the bags, and arrange them inside shipping cases. It may look like the final step, but the packaging also protects the fries from moisture, freezer burn, contamination, and quality loss. It is the last barrier between the factory and the consumer. And this is where one rule can never be broken: the cold chain. From the factory to the distribution center, from the truck to the grocery store, and from the stockroom to the freezer, the fries must remain frozen. If they thaw and freeze again, ice crystals can grow, the texture can deteriorate, and the final result will not be the same. The crispiness that seems to come alive in your air fryer actually depends on an entire journey under controlled temperatures. And this may be the most remarkable part. Frozen French fries are one of the clearest examples of how the food industry transforms a simple ingredient into a predictable product. A potato is still a potato, but the experience that reaches the consumer is the result of agriculture, engineering, logistics, quality control, and extreme cold working together. So the next time you reach for a bag in the freezer aisle, remember this. Those fries began hidden beneath the soil, were lifted from the ground by massive machines, passed through a precision-driven factory, and traveled frozen all the way to the store. If you enjoyed seeing this process from the inside, subscribe to Factories and Facts and tell us in the comments what surprised you most. Was it the farming, the steam peeling, the par frying, or the freezing tunnel? And after seeing everything these fries go through, will you ever look at a bag of frozen French fries the same way again? And if you think you have already seen everything, then you have no idea what we revealed in our previous episode. It is already appearing on your screen. Click it and come with me to uncover another hidden secret here on Factories and Facts. Take care. I'll see you there.